Welcome to Chemistry. This is Mr. Jackson. Today I want to go over a quick review of naming and writing correct chemical formulas. If you cannot do this, you will struggle in all this next trimester. The first trimester, all the formulas and stuff are used heavily in second trimester. So everything you've learned is going to, a lot of things you're going to be using over and over again. So you have to have mastered what we went over in first trimester. So really quick, I want to talk about elements. We've talked about this already, but some basic ideas will help us with our formulas. We have this heavy black line that goes through the periodic table right here between boron and aluminum. It's a nice step line. Everything over here is called a non-metal. Okay? That's all of these materials right here. Everything else, including this lower box, are metals. Okay? They have different names for the metals. These are the transition metals here in the center. And these are the alkali and the alkaline earth metals. But each table and group will gain or share electrons differently. These love to give away electrons, and they love to become ions with a +1 charge. These love to be +2. The transition metals, however, like to be +2, +3, +4, +6. These you can't memorize, but because they vary so much. Over here, these like no charge, so they basically stay neutral all the time. They don't want to gain or lose electrons. These elements love to gain 1 electron and be like the noble gas. So these love to gain an electron and become -1, and ones that gain 2 electrons, and these like to gain 3 electrons. Okay, but now you're in the middle here, and then if you go across, since these are in, this one goes to here, we go over here, it becomes +3. Now, carbon is very unique. It can be +4 or -4. It falls right in the middle of the octet rule. So it can be go 4 this way or 4 backwards. So it all depends. But that's some basic things I want you to remember on the periodic table. Non-metals, metals, there's a separation. These like +1, +2, and +3. -1, -2, and -3, and this one falls right in the center. These are transition metals, and they have various charges. Now, how does that help me? Well, that helps me because every element, when they come together, elements, when they get near each other, they like to share electrons, okay? And so what happens is an atom, when it comes near another atom, it checks out its outer shell. And if the outer shell is just missing 1 or 2 electrons, and this one has 1, it would like to give them away. So we talked about that in the first trimester. Okay? And so when they've lost or gained electrons, the losers become positive, and the gains, ones that gain electrons, take them on, become negative, and those opposite charges attract each other. And so in most formulas, which are called ionic formulas, are made up of ions. And usually those ions come from opposite sides of the periodic table. That means a metal, which likes to be positive, has joined with a non-metal. And that's how it's easy to recognize a material that's going to be ionic in nature. They come from opposite sides of the stair step. Okay? So let me give you a quick rules to go over to remember how to write them. We write down our rules right here. I'm going to go over them really quick with you. Our first rule for writing ionic formulas is as follows. We know, I'll bring this in a little closer, that the positive ions are always written first. So if I have 2 ions, let's say I have chlorine -1, okay, which is right here, and I've got with sodium +1. If I want to write a formula, I must write them together, but I have to put the positive one first. So I put the Na first and the Cl second. So whenever you see a formula, the positive one, the one that likes to give the electrons away, has been written first. Okay? So this is the correct formula for these two. The next rule is, you have to remember, every time, whenever you put them together, the positive charges must be equal to the negative charges. So here I have a +1, and that equals the opposite -1. So if you added these two numbers, you would get a 0. So if I have, let's say I've got calcium, which is +2, okay, which is right here, and then I put it with oxygen, who is -2, okay, then if I add those two numbers together, will I get 0? Yes. So I just simply put them together and I write the calcium first and the oxygen second. So every time you put them together, if their charges equal 0 when you add them, then you're already a balanced formula, just put them together. But what if these charges don't match? Well, I made up a little idea called crisscross, and I've seen it used more and more over the years by a lot of other people. It's if it crisscross, you can always make a formula fit this rule if the numbers are not equal and opposite. So let me give you an example. So let's say that we have calcium, which is +2, with chlorine, which is -1. If I put them together and I write CaCl, that would be an incorrect formula because it does not add together and get a 0 charge, and they do not balance each other. But if I take them and I do what's called crisscross, if I take this one's number from its charge and make it a subscript, and I make this one the subscript, well, I don't need to write 1s because 1s already mean there's already 1 calcium just because its formula is there. But I want to have 2 chlorines with it, then that would be the correct formula. That's what crisscross means. So if you ever have 2 ions and their charges are not the same, you crisscross and you get a correct formula that fulfills Rule B. Okay? So let's say I do it this way. Let's say I have a formula with, let me see, salt. Let's go with magnesium, which is +2, and I'll put that with aluminum. No, let's go with -3. Let's go with phosphorus, -3. So phosphorus right here is -3. Okay, so if I want to put them together, I write the magnesium first, but since these two charges will not add up to 0, then I bring a 3 over here, and then I put a 2 on this one, and that will give me a correct formula. How I know that is, I have 3 magnesiums that like to give off a +2 charge. So that's +6. Then I have 2 phosphorus, each one likes to give off a -3. It's -6. So now they have balanced. So by crisscrossing their numbers, I generate equal positive and negative charges. So that's what you do every single time if the numbers are not the same. If they are the same, you just put them together. Okay? That's how you fulfill Rule A and then Rule B. Rule C is a simple idea. Rule C says this: if there's a polyatomic ion, use brackets. What is a polyatomic ion? It is a group of atoms like SO4 or ClO2 or C and N, cyanide, or C and O here, okay, or NH4. That means there's more than one capital letter, so it must be 2 elements together, and as a group, they're acting like an ion. So if we need to add numbers to them, we need to put brackets around them. So let me give you an example. Let's say I take this one, ammonium, which has a +1 charge. So I take NH4 +1, and I want to put it with something with a -2 charge, like sulfide. Okay, so sulfur. Then I got to crisscross. Okay, since I got to crisscross, I got to add a 2 down here. So if I did this, and I bring a 1 over, I don't need to write a 1 because the sulfur already means 1. That looks like 42. I don't want 42 hydrogens. I want 2 of these to balance that, so I must put brackets around it. And then the 2 goes outside. So that means I have a sulfur attached to 2 NH4 groups, if that makes any sense. Okay? So we need to add brackets if we bring numbers down around a polyatomic group. Okay? So that's how that works. Let me try another one. Let's say I've got calcium with hydroxide. And since they're not the same number, I got to crisscross to make a balanced formula. So I need 2 of these OHs. So what I want is I want 2 OHs attached to it, like that. So I got to put Ca, and then I want brackets OH, and then a 2 outside, so that there's 2 OHs attached to the calcium. Okay? And that's kind of what I'm thinking about. So that's how you satisfy all the ionic formulas. Okay? And you need to understand that. How do we name these formulas? Okay, well, it's not that difficult. It's just a reverse process. the first thing you do is you basically look at the formula and you name the positive ion first, which of course is in the front. So let me give you a formula. NaCl. You cut them in half. This is called sodium. Okay? And then this one's called chlorine on the periodic table. It's called chlorine. Okay? But if it falls into the second half, the negative ions have a small name change. If it's just a single element over here, only one kind, and there's just chlorine over here, it ends in "ide." So this would now be called, instead of sodium chlorine, it'd be called sodium chloride. Okay? If it was another one, let's say I had some subscripts. Well, subscripts don't change the name. Let's say I have sodium, and sodium is with oxygen, and remember, oxygen is -2, so the 2 goes down. So if this is +1 and -2, I need to bring a 2 down. So this is how I would find the formula for sodium oxide. But it's called, I cut it in half to name it. The Na doesn't change its name if there's 2 or even its charge. It doesn't make a difference. Whether it's an ion or an element, it's still called sodium. But then the negative half has to end in "ide" because it's only oxygen. So instead of calling it oxygen, I would call it oxide. Okay? Oxide. And that's how it ends. So that's how you do it. But we have a couple other names we need to give out too. So let's do a couple more here just to practice a few more. Let's go with, let's say we have Mg(I2). Okay? You just cut it in half, name the first half, and it uses the same name from the periodic table, magnesium, and this is iodine. But since it's on the negative half and it's only iodine, and remember, it means it's single does not mean it's by itself. It just means that it's only one type over here. There's only iodine ions, so it ends in iodide. Okay? So that's the "ide" ending. Then there are 2 other endings for the negative side that can change. If you have a polyatomic group attached in here, you got to end, and a polyatomic group has oxygen, you have to end in "ite" or "ate." Well, what does that mean? Well, let's look at it. Let's say that we have, let's go with MgSO4. That came from magnesium being put with a polyatomic group SO4 -2. Okay. Now I have this ion sheet in your notes, so keep this close by at all times. These are the most common ions we run across in chemistry. Okay? There are other ones, but for this level of chemistry, these are the most common ones. So SO4 is a polyatomic ion with a -2 charge. Magnesium is +2. Okay? And so it would look like this. Now there would be no crisscrossing because those 2 numbers, when you add them together, you make 0. So that's the formula. So how do I figure out the name? Well, you always cut it pretty much mostly after the first element. And remember, the first one never changes its name, so that's magnesium. Okay? Now the second half has more than one element, so now it's going to have a name beyond sulfide. It's going to have oxygen. If it has oxygen at the end in the negative ion, you have to end with "ite" or "ate." And the rule is this. If there is 2 of them, one has less oxygen and one has more, the one with more oxygen ends in "ate. The one with less oxygen ends with "ite." So here's one over here. There's chlorite and chlorate. Here's chlorine with 2 oxygens. Here's chlorine with 3. The one with more oxygen ends in "ate, chlorate. If there's no oxygen, it's just by itself, it's single, it ends in "ide." So that's the rule. Ide, "ite," less oxygen, "ate," more oxygen. So this has more oxygen than the "ite," so this would be called magnesium, and it starts with the first name of the first element it's with. It's sulfur, so it's sulfate, and the "ate" comes from the oxygen. Okay? So that's how you name elements, okay, and compounds, and you name them using these ion rules, and these you need to keep close by to practice because it's not easy at first, but if you use this sheet, you will always be able to name things and make correct formulas very quickly and very efficiently if you follow these rules. Okay? Last rule I need to show you about ionic equations and formulas is there are Roman numeral in some names. And that is because these transition metals we talked about earlier can have multiple charges. Chromium likes +4, it likes +3, it can be +6, iron can be +2 and +3. But we can't memorize all those, and there's only some more, the most common, like iron's very, very common. Copper is very, very common. So is zinc. But, tungsten is not a real common metal to dig out of the ground. So the most common ones we're going to use that we need to know how to use this naming system is these 4 right here. So I'm going to use copper, iron, lead, and tin. These are the most common ones we run across at this level of chemistry. Here's what I mean when you run across a transition element. That means the ones from the middle of the periodic metals, from the middle of the periodic table, the D block. What you do is when you have those in a formula, you must put a Roman numeral in the name. Okay? So what that means is it's telling you the charge it is using in the formula. Let me give you an example. If I put iron that has a +3 with chlorine -1, I would find the formula as Fe, remember crisscrossing, FeCl3. How would I name it? I'd cut it in half, and it would be called iron, okay, because the first element never changes its name, same name as the element name from the periodic table. But remember we said if it's single, it ends in "ide," but if it's attached to a transition metal, transition metals sometimes can have multiple charges, and I have to tell you which one it's using. So iron likes +2 or 3, so if it's in a formula, I have to add something to its name. This would be called iron chloride. But this would be FeCl2. This would also be called iron chloride. And the problem is we don't know which one is which because I can't tell which one is using the charge. So from the formula, so if I can name it, I want you to know what charge it has. This one is using a +3 charge, so we're going to name it iron 3 chloride. So we put a Roman numeral 3 in the center. This one's going to be called iron, since it's a +2 charge, iron 2 chloride. Okay? So the Roman numerals in the middle of a name means you're dealing with a transition metal in the middle of the periodic table, and you're indicating what charge it's using in that particular formula. So if you look up the negative ion and that charge, you can get back to the correct formula each time. So let me give you one more example. Let's say I used, let's go with copper carbonate, so you have CuCO3. Okay? How would I name this one? Well, I cut it in half, so I know I have copper. And then I got a group, so I'm going to go to my polyatomic names. I find it right here. It's called carbonate. But since copper comes from the middle of the periodic table of transition metals, I need to use a Roman numeral in its name. Copper likes +1, sorry, over here, +1 and +2. So it's got to be one of those. So I got to either put a Roman numeral 1 or 2 in the name. Here's how I do it. I look at the negative ion. It is carbonate. It is -2. There's only one of them because there's no bracket around it. So this side has to have a +2 charge to balance. So that means each copper must be worth 1 to get up to a +2. So this is copper 1 carbonate. Okay? So the Roman numeral means that you're dealing with a D block transition metal, and those are indicating the charge. So this has a +1 charge, and that charge goes into the name as a Roman numeral. Okay? And that is how you do ionic names. So I want you to remember that as you're doing these, okay? Thank you for joining me.